In this video, I'll talk about the motion of the charged particle in both electric and magnetic field. That means both electric field and magnetic field are present. What happens to the electric field? In which direction it will move? What is the net force acting onto it? That I will be talking in this video. So we know that the force acting onto a charged particle in an electric field, just in an electric field, is given by q e vector. So this is the force acting onto a charged particle when it is in electric field. Okay, if the charged particle is in a magnetic field, then the force acting onto a charged particle due to a magnetic field is given by v cross b vector. So this is the force acting onto a charged particle. And if both fields are present, both electric field and magnetic fields are present, then the net force, the total force, is given by this equation here. And this is the electric force and this is the magnetic force. The net force will be the vector addition of these two forces. Okay, and here are the few important points I would like to make from this equation. This equation, which is the electric force, does not depend upon the velocity, does not depend upon the speed, the magnitude of the velocity. Okay, but the magnetic force does depend upon the velocity. The electric force, this electric force changes the speed of the particle. It can either accelerate the charge or it can deaccelerate the charge, or it can speed up the charge or it can slow down the charge. The electric force can speed up or it can speed down or slow down charged particle. Okay, but the magnetic force here, but this magnetic force does not change the speed at all. Remember, this is such an important point. The magnetic force does not change the speed, it only changes the direction. And the reason is the magnetic force, this magnetic force is perpendicular to the speed direction or the velocity direction. The magnetic force is perpendicular to the velocity. That means it cannot change the speed. Just like the earth is orbiting around the sun. In that case, the force, let's say here in this case, here is the earth and this is the sun here, this is the earth. In this case, the force is acting perpendicular to the velocity direction. As the force is acting perpendicular to the velocity direction, it will only change the direction, and that's the reason we have a circular orbit here. It does not change. There is a force acting onto it, but that force is not changing the speed or the velocity. It is in fact changing the velocity because the direction is changing, but the speed is not changing at all. It only changes the direction. But in the case of electric field, it changes only the magnitude. It does not change the direction. So that's the two important differences. So the magnetic force can only change the direction, it cannot change the speed. The electric field only changes the speed, it cannot change the direction. The electric field does not depend upon the velocity, but the magnetic field does depend upon the velocity. And here is one of the picture that will tell you all the differences here. Now let's say we have a charged particle here. This is the charged particle, and the charged particle is moving in this direction here. That's the velocity direction. I can call this as a x direction. Let's say this is x, and let's say this is y, and this is g direction. You can call whatever direction you have, but let's call this x, y, and g direction. Okay, so in this case, the magnetic field is acting along y direction. This is x, this is y. If and under this magnetic field, the magnetic force will be perpendicular to both the velocity and the magnetic field direction, and which is along the g direction. Okay, it is perpendicular to both magnetic field and both velocity and the magnetic field. And the magnitude of the force is given by this equation, q vb sine theta. And what you see, when a charged particle enters a magnetic field, then it starts moving into a circular path. So this is the circular path here. It will starts moving into the circle. Okay, so we remember now, whenever a charged particle enters into a magnetic field, it will start moving into a circular path. Okay, and now what happens if there is only electric field present, no magnetic field? So this is a charged particle and the electric field is again along y direction. So in this case, the force due to the electric field will be along y direction. And now consider the case where both electric field and magnetic field are present. What will happen in this case? So this is the situation here. So in this case, you see, this will be the spiral path. And why a spiral path? Because due to the electric field, the particle or the charged particle will move along y direction, and due to the magnetic field, it will move into a circle, and as a result, the path will be helical path or a spiral path. The spiral path, if you look at the spiral or a spring, it does have a circular arc, as well as it does have a linear path as well. So due to the electric field, it moves into the y direction, and due to the magnetic field, it moves into a circle, and as a result, and the combination of both is the spiral path. Okay, so the in this case, the force would be given by q e vector plus q v cross b vector. Okay, and in this case, the force due to electric field is simply q e vector in electric field, and the force due to the magnetic field in this case is q v cross b vector. If you have taken calculus class, and this is only for the University Physics 2 classes, not for the college. If you have taken the calculus class, then if you know the direction, then you can in fact solve or find out the direction of the final velocity or the final force. All right, so here I have chosen the electric field and magnetic field both in the same direction, but it is not necessary to be in the same direction. It can lie along any direction, and in that case you have to use this equation or the vector product to find out the direction, and I'll talk about this one in a separate video. So the lesson from this video is that the magnetic force changes the direction, the electric field changes the magnitude. The electric force does not depend upon the velocity, but the magnetic force does. Okay, so this is the example here, and this is the equation. So this is it from this video. If you have any questions, write down your questions in the comment section below, and do not forget to like, share and subscribe the channel.